Hello everyone. In this tutorial, we'll be learning how to interface the IR tracker sensor with Arduino Uno in Proteus simulation. This project helps us to understand how IR sensor detects reflected infrared light and how the Arduino processes these readings to determine the presence of an object. We'll also display both analog and digital readings on the 20x4 LCD, giving you a complete view of how this sensor works in real time. First of all, I would like to clear some concepts. The IR tracker sensor module contains an infrared transmitter and the receiver photodiode. When an object comes closer to the sensor, the emitted IR light reflects back to the receiver and the module outputs a high signal to indicate that object is detected. The digital signal is also connected to the onboard LED, which turns on whenever the reflection is detected. The analog pin A0, on the other hand, provides the varying voltage based on the intensity of the reflected light, which is then displayed on the LCD. In Proteus, we use the potentiometer instead of the physical surface to emulate the reflected intensity. By increasing the resistance, the output voltage increases. That is simulating a stronger reflection. Just like when an object comes closer or farther to the sensor. So before moving towards the simulation, I would like to tell you that you have to install three basic libraries to start this project. The first one is obviously the infrared tracker sensor library for the Proteus. The second one is the new LCD library, and the third one is the Arduino library for the Proteus. I will provide the link of all of these in the description. So let's move towards our ready circuit. As you can see here, this is the ready circuit. This is our sensor and it has four basic pins. This is the analog pin connected to the LC circuit. LC circuit is required only in Proteus. You don't have to add this circuit when you are working with the real-time project. This is the digital circuit, digital pin. This is the ground pin and this is the voltage pin. As you can see, the potentiometer is connected to the test pin. So by varying the resistance of this potentiometer, you are varying the values on the analog and the digital pins. These values through the Arduino are then programmed. So you can see that the analog pin is connected to the analog pin of the microcontroller and the digital output is connected to the digital pin of the microcontroller. So whenever the user is changing the values here, the change in the voltage and the digital signals are then fed into the microcontroller that convert these changes into the IR readings, and these readings are then displayed here on the LCD. To make the project workable, we'll need to program the Arduino in the Arduino IDE. But before starting coding here, I must tell you that you will need the LCD library installed before pasting the code here. So once installed, you can paste it. This is the liquid crystal library that will allow us to use the features of LCD. These are the pins of LCD connected to the microcontroller, that is Arduino. We have defined the analog and the digital pin that are connected to the particular pin of the Arduino. This is the void setup. I am using it to display the title of the project. You can use the text here. You can change it or use it as it is. So the title of this whole project will be displayed on the LCD for 2 seconds. After that, Arduino will continuously check this loop function. In the loop function, I have simply designed the code so the microcontroller will continuously read the analog and digital signals from the sensor, will convert it into the IR values and will display it on the LCD. As you can see, I have used some loops to provide the information about the status of the IR sensor based on the user's input. So to make the connection between the code and the microcontroller, you will need to have the address of hex file. Whenever we compile the code for the first time in our system, it creates a hex file, and we just need the address of this hex file. As you can see here, I have this. So I just have to copy it, only the hex file without any quotation marks. See, it is ending with the extension hex here. Copy it, go to your simulation, double click your microcontroller and paste the address into your program file head address. I have done it before. Click OK. Another step is to provide the hex file of the sensor you have just installed. If you have installed it for the first time, if you're using it for the first time, you will have to provide the hex file address to this as well. So you simply have to click on this and direct it to your library folder of the Proteus. Click OK. Now this is all ready. Let's test if our project is working as expected. This is the title, as I have mentioned before in the code. So at the moment, the potentiometer value is 0%. So our digital output is 0, our voltages are 0, and the same information is shown here, that there is no object, the digital values are 0, the analog values are 0. So whenever the user change it and the value of potentiometer increase beyond the threshold value, you can see the LED is now turned on at 100% resistance. The voltage is here 100%. So our LCD says that the analog value is maximum, digital signal is high, and the status is the object is detected. So in real time, you can say that the signal sent by the sensor are reflected to something. This may be anything, any animal, anything, or human, and that is reflected back to the sensor, and it is showing that the object is detected. I hope this was a useful project for you, and if you have any question, you can ask in the comment section.